Hi, welcome back to the part 2 of the test I gave to my 11th graders over the week, and we couldn't finish solving all. I think we solved the first 3 questions and we used about 30 minutes. Question number 4, it's on calculus, differentiation to be specific. So with this one, it's talking about, the first part is actually talking about it's testing your ability of functions. We have to explain why the curve doesn't exist when we have x to be less than 2/5. So when x is less than 2/5, you would realize that the number inside the square root will be negative, and this is going to take us to the complex plane, which in our O-level IG we are not really interested in complex numbers. We would look at that one when it gets to year 13, hopefully, in pure maths 3. The value of the function will be undefined, and if you want to go further, you can talk about asymptotes and other things, but generally it's going to make the square root have a negative number, which is going to distort almost everything. So that is just a short explanation for 1 mark. Now the next thing is to show that the y dx can be written as this. So I told my students that is how I used to remember the differentiation. You can also use that k dt, keep down, differentiate top, because subtraction is not commutative. So the way you start the quotient rule is very, very important. If you don't so like the quotient rule, you can quickly you can basically change the quotient rule into a product rule, but I'm not going to do that in this video. So let's go to the differentiation. So the y dx in this case is going to be keep down x minus 3, differentiate top. There's going to be 1/2 square root of 5x minus 2 multiplied by the differential of 5x minus 2, which is 5. There will be a separate video on how I did this in less than 10 seconds, so there is no need to change it back to exponent 1/2. There will be a short video on that. Just make sure you turn on your notification bell so that when I post something you just get to know. So keep that down 1, differentiate the top, minus you keep the top, differentiate the down. So if you differentiate this one, is 1 over the down 1 squared, so x minus 3 all squared. So let's simplify this a little bit. So this is this can be written as 5x minus 15 over 2 square root of 5x minus 2. If you are wondering what I did, I multiplied this 5 by this bracket outside, then multiplied it by 1. So minus square root of 5x minus 2. Again, for me not to confuse myself, let me put all this in brackets, then the division symbol, then x minus 3 all squared. Okay, now finding the LCM to this one would give you 2 set 5x minus 2. This multiplies this, or this divides that, and I'll be left with 1, and 1 multiplies 5x minus 15. Similarly, this is divided by 1, so the quotient would be the same fraction or the same set. So there's going to be 2, then set 5x minus 2 multiplying set 5x minus 2 is basically set 5x minus 2 all squared, multiplied by 1 over x minus 3 all squared. So there can be some cancellation. This cancels out. I'm leaving you with 5x minus 15 minus 10x plus 4 over 2x minus 3 all squared, square root of 5x minus 2. We can simplify the top. That should give us negative. Is it negative? I'm getting negative 5. So negative 5x minus 11 over 2x minus 3 all squared, square root of 5x minus 2. So there's the same as writing negative out, 5x plus 11. Then this divided by the quantity 2x minus 3 all squared, then square root of 5x minus 2. Let's look at the question. So okay, in this case a is equal to 5 and b is equal to 11. So yeah, we are good to go. A equal to 5, A equal to 5, B equal to 11. Okay, so that answers the question. And the second one, differentiation. This is the chain rule. So in this case, the y dx would be 12. Differentiates everything. So 12, 3 minus 5x raised to the power 11. Then multiply this one by the differential of what is inside. So the differential of 3x minus 5x, 3 minus 5x is going to equal to negative 5. Simplifying this further, 12 times negative 5 will be negative 60. Then we've got 3 minus 5x raised to the power 11. The second one, this product. So for product, you keep the first one, differentiate the second one, then you do the reverse. So the y dx in this case is going to be equal to, keep the first one, differentiate the other one. If you differentiate sine, you get cosine. Then you keep the sine x and differentiate the x squared, which is going to get you 2x. Let's clean this up a little bit. So x squared cos x plus 2x sine x. Be careful not to multiply this 2. The x is the argument for the sine. This is just something multiplying the entire function. So be careful not to write this one as sine 2x squared. That will be very, very wrong. So that answers this question as well. And there's also a quotient rule, kd dt, keep down, differentiate top. So my dy dx in this case will be, keep the bottom one, 1 plus e 2 raised to the power x, differentiate the top one. If you differentiate tan x, you get sec squared x. Then minus, keep the top one, tan x, differentiate the bottom one. If you differentiate 1 plus e raised to the power 2x, you're going to get 2 e raised to the power 2x divided by the denominator squared, 1 plus e raised to the power 2x whole squared. Again, there should be a video on differentiation of the exponential functions and differentiation of the trigonometric functions as well. So just check my page and that will be that. I don't think we can simplify further, so let me just clean up a little bit. 1 plus e raised to the power 2x sec squared x minus, here don't forget to put this in brackets, otherwise it would be assumed that e raised to the power 2x is the only one multiplied the sec squared x. Then 2 e raised to the power 2x tan x all divided by 1 minus 1 plus e raised to the power 2x all squared. I wonder why this is 4 marks. I think it's too much for this. Okay, so that was the, we've got one more calculus question. I think the calculus part won't take as much time. This is saying that it's given that y is equal to mx squared plus x over 2 plus n, where m and n are non-zero constants. It's also given that 3 the squared y dx squared is equal to dy dx all squared minus y for all values of x. This statement is very, very important for all values of x, which makes this an identity. So if this is an identity, what tells me, what I can actually make out from this would be that I can substitute any value at all, and I can also do comparison. So I'm going to use that strategy in this question. But first, we can see dy dx. So let's find dy dx, and we find the squared y dx squared, and figure out how to continue from there. So dy dx, at least let's get 1 point, will be 2mx plus 1 over 2. Yes, be careful not to miss the 1 over 2 as well. Then the squared y dx squared would be, differentiating this again. If you differentiate 2mx with respect to x, you get 2m. If you differentiate 1 over 2, it goes to 0. So these are the two things we're going to substitute. Yeah, so we have to find m and n. Let's be a little bit smart about this one. Since this is true for all values of x, let's isolate the y, and we can set it up for comparison. So we've got 3 multiplying the squared y dx squared is equal to dy dx all squared minus y. Isolating the y would be y is equal to dy dx all squared minus 3 the squared y dx squared. Now y was given the question as mx squared, so let's just write this one down. Mx squared plus x over 2 plus n, just to confirm. Here, we're good. Is equal to dy dx. We got dy dx to be 2mx plus 1 over 2. So this squared minus 3. The squared y dx squared was 2m. Okay, so let's do some expansion for this. You take your time and expand this side. If you know the shortcut, it's fine. You can go with the shortcut. So I would go with the shortcut. You square the first one. This will give you 4m squared x squared. We multiply the 2mx times 1 over 2 will give you mx. Multiply the results by 2. So this gives you 2mx. Then 1 over 2 squared will be 1 over 4 minus 6m. Okay, so with this one we've got mx squared plus x over 2 plus n. Let's see if we can clean this up a little bit. I think, man, that is all. We can't really do anything about it. So let's compare the x squares. So 4m squared to m squared. So I can say that m is equals 4m squared. We've got two possibilities over here. So 4m squared minus m is equal to 0. Factor out m, we get 4m minus 1 equal to 0, where m equals to 0 and m is equal to 1 over 4. Just take your time and do this one. That is 4m minus 1 is equal to 0. Then let me just do it. I have some time. So 4m minus 1 equal to 0. So m is equal to 1 over 4. Okay, so let's see if this would work out with this one as well. So there's 1 over 2. Then there is 2m. So 1 over 2 is equal to 2m. The good news is checks out. So we are good to go. Then the last comparison we're going to do is going to be this n with this entire thing, items without x. So I can say that n is equal to 1 over 4 minus 6m. So n is equal to 1 over 4 minus 6 of 0 for first value for m. So that's going to be 1 over 4. Or n is equal to 1 over 4 minus 6 of we got the other value to be 1 over 4. So let's work this one out. I think it's be negative 5 of 1 over 4. Anyway, let's 1 over 4 minus 6 of 1 over 4. That's quite strange. Okay, 1 over 4. So negative 5 over 4. So n equals negative 5 over 4. And that should answer the question. So m equals to 0, n equals to 1 over 4, or m equals to 1 over 4, n equals to negative 5 over 4. Can we cross check? No, I don't really have the luxury of time. So that's for this question number 6. Then that is the end of the calculus aspect of the question. So let me pause the video right here so that we continue with the part 3, that is the trigonometry aspect. Bye bye for now.